Alright, we're going to do the exam 2 video portion here. I'm going to do problems 1, 3, and 6. You said I can use my notes, so I got my notebook right here. It says I can use this formula sheet, so I got that right here. And then the problems open on this tab right here. That's all I got open. That's all I'm going to use. So yeah, I'll go ahead and get started. Starting here with number 1. So I'm finding a general solution using variation of parameters. Okay, that's cool. That's fun. Tangent of 2x. Super cool. Thank you for giving us that one. It's gonna be a lot of fucking fun, huh? Alright, so first thing I'm gonna do is I'm gonna solve the left hand side first. So I'm gonna set that equal to 0 and figure out what the r's are. So I'm gonna be like r squared plus 4 equals 0. Okay. Alright, I'm gonna use the quadratic formula to figure out r. Alright, so we got plus or minus the square root of 16 over 2. So I know it's going to be case 3, because I'm going to have the imaginary number here. This simplifies to, 4 over 2, or plus or minus 4 over 2i, which is just 2i. So I know my alpha is going to be 0, because there's nothing in front of the plus or minus. Beta is going to be 2. So, y sub c is going to be C1, how's it go, C1 cosine, I think 2x, right, because that's where the beta goes, plus C2 sine 2x, alright, there would be an e out front of all this, but it's not going to be there because alpha is 0, so that's just going to reduce to 1, so I didn't even include that there. But that's going to be our y sub c part. So now I'm going to find y sub p. So using variation parameters, y sub p is going to be u1, y1 plus u2, y2. I'm going to have this be the y1. Sine squared will be y2. Okay. Okay, so... Oh yeah, I need to find the Wronskian. Wronskian of y1 and y2, so that's going to be cosine 2x and sine 2x. Derivative of cosine 2x is, what is that, minus 2 sine 2x, right? And derivative of sine 2x is 2 cosine 2x, chain rule and all that. So with the matrix, we're going to have 2 cosine squared 2x minus negative 2 sine squared 2x. Okay, so that's just going to be an addition part here plus 2 sine squared 2x. So from here, I can factor out this 2, and then a trig identity, cosine squared plus sine squared is going to be 1. So the Wronskian is just going to be 2. Alright, so we'll find u1 using this formula here. Minus integral y2 fx. It's going to be minus integral. So y2 is sine 2x times, so f of x is going to be tangent 2x over 2. Alright, and how do I integrate that? Okay, well, tangent of x is sine over cosine, so be sine squared 2x over 2 cosine 2x Does that help? No, not really. So does U substitution even work here? Because like if I set u equal to sine of 2x, when I solve for du, I'm just gonna have another cosine on the bottom, so that doesn't cancel that out, so that doesn't work. I don't think integration by parts works either, does it? Because I mean, like the sines and cosines, like that's not really going away. Oh, whatever. I'm just leaving. It's gonna be u1 right here. I'm just gonna leave it like that. All right. u2 equals. So y1 is cosine 2x times tangent 2x over 2. Okay, well this one cleans up better because it'll be when I substitute sine over cosine for tangent, the cosines will cancel, so I'll have sine of 2x over 2. So it's 2x. Okay, so equals sine u over 4 equals, what is that? Minus cosine, resubstituting 2x over 4, right? Right? Yep, okay. So that's u2 right there. Alright, so the general solution y equals yc plus yp. So our y sub c is, I already found that, c1 cosine 2x plus c2 sine 2x plus our y sub p, so u1, and minus, oops, there's a minus here, sine squared 2x over 2 cosine 2x dx times y1 cosine 2x. Okay, plus, or no, excuse me, it's going to be a minus because of that right there. So minus cosine 2x over 4 times sine 2x. Okay. It's a general solution, right? Yeah, general solution, no given initial conditions. So there we go. There we have it. Y equals c1 cosine 2x plus c2 sine 2x minus the integral of sine squared 2x over 2 cosine 2x times cosine 2x minus cosine 2x over 4 times sine 2x. So yeah, that's the general solution. Once again, I'm not even going to try that integral. I don't know. I don't think u sub works. I don't think integration by parts works. I don't know any trig identities that are going to help. So hopefully that's good enough there. Get a picture of this for submission. I might just rewrite like all this like on paper when I submit the main test. Hopefully you don't mind or anything, but get a picture just in case. Okay. Okay, let's move on to number 3 here. Use any method to find the particular solution. Okay. Alright. we'll start off with the left-hand side. We have r squared plus 4r plus 4 equals 0. So what does that factor to? Is that just r plus 2 times r plus 2? I think so, right? Yeah. So it's going to be case 2, the repeated real roots. So r1 and r2 equals 2. So how does that go? C equals c1 e to the 2x plus c2x e to the 2x, if I'm not mistaken. Right? Oh, it'd be minus 2, right? Yeah, it'd be minus 2 because minus 2 fits in there. So that's what R1 and R2 equals. Okay. Alright. Let's do variation of parameters, I guess, because it's still kind of fresh in my mind. Y sub t equals u1, y1 plus u2, y2. y2. Okay, so we're going to need the Wronskian again. E minus 2x and x e to the minus 2x as our y1 and y2. So let's see here, derivative of that is minus 2 e to the minus 2x. Oh, is this a product rule? Yeah, it's product rule, right? It says f, g. So f prime is 1, so e to the minus 2x plus x e to the minus 2x times minus 2, right? So minus 2x e to the minus 2x. Okay. Alright, so doing the cross multiplication, all that, we have e to the minus 4x minus 2x e to the minus 4x. Or be x squared, right? Or no, because it adds, right? Yeah. Minus okay, so this is going to turn into a plus because of double negatives, so these are just going to cross out as the same thing. So my Wronskian looks like it's e to the minus 4x, right? I think so. Okay. Now what? Okay, we need u1 again. Let's do that up here. So u1 equals minus y2 x e to the minus 2x times 10 e to the minus 2x, or fx, divided by the Wronskian, e to the minus 4x. Okay, this is a lot better because I think all this e shit, I think all that goes away. So we have that minus 10x, right? Because you can break this e to the minus 4x up into 2 e to the minus 2x's. So that'll just all cancel out. So I've got integral of the negative integral of 10x. So that's just, 10x squared divided by 2. 1 equals minus 5x squared. How does that look? Does that look good? Yeah, I'll call that good. Alright, u2 equals. The hell's my y1? E to the minus 2x. 10 e to the minus 2x divided by e to the minus 4x. Okay, so this one's just the integral of 10, which is just 10x. So that's nice and easy. Alright, so our y sub p equals minus 5x squared e to the minus 2x plus 10x x squared e to the minus 2x, because y2 has an x in there. So that's our y sub p right there. So let's see, let's go and put that together. Oh, I can condense this actually. So that'll be plus 5 e to the minus 2x, because minus 5x squared e to the 2x plus 10x squared e to the minus 2x is just going to be 5. Okay, so that makes that a little bit easier. So that's our general solution right here. So I'm going to find the derivative of that. So what is that? Minus 2c1 e to the minus 2x minus 2c2. Oh, there's going to be a product rule there, huh? That's great. Yeah, thank you so much. Appreciate that. So okay, so that's the product rule right there. For that one, then I gotta do product rule for that one too. That's cool. Yeah. Not a problem. Plus 10x. So it's gonna be minus 10x x squared e to the minus 2x, right? Okay. So now we'll use our initial conditions. We'll find C1 and C2 equals C1. So when you plug 0 in for the x's and these e's, they're just going to go to 1. So I'm not even going to write them down here. Oh, this is just going away, and so is that. Okay, so when you plug it into the initial one, we find that C1 equals 1. So that was easy. Because the other two terms are just going to go away when you set x equals 0. So y prime 0 equals 1 equals minus 2 C1 plus C2. Then everything else in here has an x in it, so it's just going to go away. I'm not even going to write it. So that leaves us the equation 1 equals minus 2 C1 plus C2. So I can plug 1 in for C1. So 1 equals minus 2 plus C2. So adding 2 to both sides, we get C2 equals 3. Right? Right. Unless I'm missing something here. Alright, yeah, so we got C2 equals 3. So the final solution is y equals e to the minus 2x plus 3x e to the minus 2x plus 5x squared e to the minus 2x. Okay, so there's our final solution right there for number 3, with everything accounted for. So I'll get a picture of this, and then we'll move on to number 6. Okay, I'll see all my work real quick before I erase it. number 6 here, solving an initial value problem using the method of undetermined coefficients. Alright, so we'll solve for y sub c first. R squared plus 3r plus 2 equals 0. What does that factor to? R plus 2 times r plus 1, right? Yeah. R1 equals minus 2, R2 equals minus 1. Okay, so it's going to be case 1 of the distinct real roots. So y sub c equals c1 e to the minus 2x plus c2 e to the minus x. Okay. Alright, now to find y sub p, and we're using undetermined coefficients. So on the right hand side here we have a second order polynomial. So that means my yp guess is going to be ax squared plus bx plus c. Because even though we don't have like an x or a constant over there, we still have to include that here, I guess. So yeah, so now what do I need? I need yp prime, which is 2ax plus b, and yp double prime is 2a. Okay, so we'll go ahead and plug all this in here now. So we have 2a plus 3 times that, so it's going to be 6ax plus 3b, plus, then we times all that by 2, so 2ax squared plus 2bx plus 2c equals 4x squared. Okay. Okay, so we're going to have the equations 2ax squared equals 4x squared, 6ax plus 2bx equals 0, and 2a plus 3b plus 2c equals 0. So for this top one here, so we're going to have 2a equals 4, so a equals 2. Plug it into here. So we're going to have 12 plus 2b equals 0, right? So b is going to be minus 6. Just plugging that into there. So we're going to have 4 minus 18 plus 2c equals 0. Minus 14 plus 2c equals 0. So what is c? So c equals 7. So squared plus minus. Okay, so that's going to be our y sub p right there. So when we throw all that together, y equals yc plus yp. Okay, now we're going to solve for C1 and C2 using our initial conditions. So I'm going to find y prime. Can you even see that? Well, I'll move out of the way. So we're going to have, it's going to be long as fuck, huh? Alright, down here. So y prime equals minus 2 C1 e to the minus 2x minus c2 e to the minus x plus 4x minus 6. Okay. Equals 1, right? Okay. So when we plug 0 in for x, these e's are just going to go away, and this 4x is going to go away. So we're going to have minus 2 c1 minus c2 minus 6 equals 1. And then for our original one, once again, the e's are going to go away when x is set to 0. And a lot of that's going away. So c1 plus c2 equals plus 7 equals, what is it, equals 0. So c1 equals minus 7 minus c2. We'll throw that in there. So 14 plus 2c2 minus c2 minus 6 equals 1. I have here 8 plus c2 equals 1. c2 equals minus 7. Yeah. So we'll shove that right back into there. So c1 equals minus 7 minus negative 7. What is that? So c1 equals 0, looks like. Yeah. Alright, c1 equals 0. So let's shove all this back into our equation here. So y equals, so this first term with the c1, that just goes away because c1 is 0. So we're going to have minus 7 e to the minus x plus 2x squared minus 6x plus 7. Okay, and there we have it. That was question number 6. Okay, picture of this. Yeah, I'm thinking I'm just gonna, rewrite this on paper and then scan it all together with my solution once I finish the rest of them. I haven't decided yet. Yep. All right. Well, that's gonna do it for the video. Those are the 3 problems I was supposed to do, and I did them. So, yep. There you go.